All right, ladies and gentlemen, if I was going to go ahead and think about the square root of 81. Now remember, there's a couple ways that we talked about doing the square root of 81. Obviously, we could break that down into prime factorization. Right? And then you could say, all right, well, really, that's the square root of 3 times 3 times 3 times 3. Right? And then we're taking square roots. We always take out pairs. Correct? And then you'd say, OK, that's going to be 3 times 3, which actually equals 9. Square root's very simple. You could also just rewrite this as the square root of 9 times 9, which we know the square root of 9 is 3, and the square root of 9 is 3. And that's, therefore, again, equals 9. Correct? So two different ways. When we're doing the cube root, the same thing goes. We can prime factorize this. Now, we already know the prime factorization is here. But now, if we're doing the cube root, we do not want to take out pairs of 3s. We want to take out groups of 3. So I'll now take out a group of 3. So then I'll have 3. This 3 is still under there, which would be 3 square root of 3. Does that make sense? And I don't have any fourth roots. But if I gave you a fourth root, then you could plug that in, correct? And you take out groups of 4. Make sense, Kate? Cool? Nothing? Good? Everything else? The other way you guys could look at this is also taking the cube root. Remember I said the cube root numbers we had that we discussed were 8, 27, 64. You guys could see that this is 27 times 3. So the cube root of 27 is 3 cube root of 3. Sorry about that. Make sure you include that 3. If you do, leave one answer out. OK? Any other questions on that? Very good. Anything else? Adding, subtracting?